All right. Good afternoon, everybody. We are here today, this gloomy afternoon, to start on this fresh subject called Business Mathematics and Statistics. Uh, my name is Udita Jayasinghe. I'm currently an employee of the Central Bank of Sri Lanka. Um, so I'll be your guide and lecturer for this course of Business Mathematics and Statistics. Unfortunately, due to the prevailing situation, we are meeting virtually today. But let's hope for the best, and if the situation gets better, we should be able to team the classes of IBSL pretty soon. Uh, uh, so to give you a brief introduction about myself, I've studied under mathematics stream. My bachelor's is on information communication technology from University of Colombo. Completed my master's also from University of Colombo under the financial economics. Um, Followed few professional qualifications also. So the whole purpose of the course that we are delivering under this program is for you to complete your first level of IBSL examination successfully. So this is an elective subject which you have chosen wisely. Alongside with this subject, we are having some more subjects. So your target should be to, on one aspect, to complete the course content on time, and on the other aspect, to be prepared for the examination without any delays. Having said that, let's. I prepared a small different slide set for you to get a bit of an understanding on the subject. Let's look into that slide set first. Don't worry, it doesn't have any theory aspects, it's just an introduction. And then after that, we'll focus on the lecture slides, which has been shared with you by the IPSL staff. All right. All right. Um, Now, this IPSL program, which you all have enrolled into, has two aspects, two stages rather. First is a stage that you are sitting under this semester, hopefully. We call it the intermediate in applied banking and finance. And then once you completed the compulsory subjects and the optional subjects successfully, you can move into the next level and become a member after completing the diploma level. So we can see there are subjects of four: survey of financial system, commercial banking, business accounting, introduction to banking and financial law as the compulsory, while you have some more optional subjects which, as per my knowledge, we have to sit for two. I've quoted this from the 2017 student manual. The highlighted subject, that is what we are sitting under this curriculum, the business mathematics and statistics. Uh, Under the student manual, these are the recommended subject coverage which we will be going through out this lecture series. Categorically, we have 11 different subject areas, but we have to be a bit careful. Not all these 11 subject areas have been tested thoroughly, but there are some subject areas which examiner has some appetite for testing more than other subject areas. For certain subject areas, we might spend 2 or 3 days, while for certain subject areas, we might finish the discussion even within one session. So after each of these subject area, we want to discuss some of the existing examination questions which your previous batches has been faced with. Why we want to follow the examination questions on the IBSL papers itself is for you to be very much prepared for the examination questions. There are many other subject areas which will be also, I'm sorry, other questions which will be also keen to share with you. But let's be mindful, we'll try to cover as much as possible the questions which has been tested over and over again in this subject. If we just had a glance through on these subject areas, the first area is to give you a very brief introduction into statistics, uh, the data, types, sources of data, and to give an understanding on the sampling methods. Second one is merely on the presentation. So we'll be focusing on how to present the data which we have learned in the first section in a tabular manner, charts, and various other formats for the management to take effective decisions. The third one is on the numerical and descriptive measures, where we'll be discussing more on the qualities of the gathered data. Sometimes you may see words like mean, median, or mode, which we use to describe the set of data which we have gathered for a particular study. On the fourth section, we will be discussing briefly on the probability and the concepts surrounding probability. We will be discussing the basic probabilities, moving on to conditional probabilities and some of the interesting formulas, and then slowly we'll move on to an area on the normal distribution, where you will be equipped with knowledge to answer questions on, for example, if you've been asked by somebody to explain under 95% confidence interval, do you think that this will happen? So those questions will be discussed under the normal distribution under section 4. Section 5. Then hypothesis testing is merely on building up a hypothesis. You sometimes call it as H0 and H1, and then testing that hypothesis alongside with the data that we have gathered. This is very important when you are conducting your future studies on research and sometimes MPhils and PhDs, where you will be invited to build up a hypothesis. That will be your study of your area, and test various conditions using the data that you have gathered. Linear regression, modeling, indices, those are sections merely on the mathematical models, which we could observe by using the advanced mathematical concepts that have been built some long time ago, where you will be introduced to define variables, and from those variables define equations and solve multiple equations, which in normal circumstances will not permit you to resolve. Modeling is all about we try to come up with equations and models to the non-world variables, for example, demand and supply, economic growth, things like that. Indices is very interesting. That is merely we try to collect a set of data and we call it a basket, and then we try to weight that basket from one point to another point, and so on and so forth. So with that, we'll be able to see what has happened to the weight of that index. One of the good examples would be inflation, right? And the last two sections are merely on various topics which we discuss under the syllabus on practical applications like bond pricing, yield curve dynamics, calculation of present value and future value, expected rate of return of portfolios, things like that. So having this brief understanding, let's focus on the structure of the exam paper, right? Why we would like to focus it right now is that rather if we wait to discuss all these 11 sections and then focus on the exam paper, sometimes you may tend to be a little bit of defocused from the examination. I explained you in the beginning of the session also, we have two targets. One is to gather knowledge after these 11 modules being completed, and on the other hand, your target should be to complete the examination in one sit and quickly move on to the next levels and complete your qualifications. So this paper has a duration of 3 hours. That's quite a sufficient time for you to get comfortable with. And also it has a reading time of 15 minutes. Now that 15-minute reading time, you will not be able to answer any questions. Rather, you are invited to turn around the pages and see what are the questions that has been put up by the examiner for the testing. Under that 15 minutes, it's very important, ladies and gentlemen, you have to select the questions that you are going to sit for the next 3 hours. How many questions? There are 8 questions typically in the recent examination papers. And the first question, like in most IBSL examination papers, the first question is compulsory. You can select 4 questions out of the rest of the 7 questions, and the individual weightage of these questions is 20 marks each. Now the first question typically comprises of MCQs, multiple choice questions, and some structured questions. Typically there are around 10 questions which each will carry around 2 marks. So 2 into 10, that is the first 20 marks. So you you have no escape there. You have to sit for that 10 marks. But when we go through the curriculum of the study, you'll understand that that questions that has been tested under this question one historically are very straightforward, and there are patterns which you can identify easily and get yourself prepared, right? Unfortunately, for this examination, unlike in some of the other examinations, you will not be provided with a set of equations or formulas to be used with. But don't get discouraged. When you look into the syllabus area, you will only find maybe a little effort to remember certain equations if you are not familiar with some of these equations. For example, if you discuss something like discounting equations, the future value, present value, 1 plus r to the n. Now that equation is being heavily used in finance. I'm sure you may have encountered in some of the other courses also. So those formulas you will be simply reapplying. You will not have to buy hard complicated equations for this examination. Except some of the relevant statistical tables you will be provided at the behind of the question paper, right? One last point I want to touch upon is that you have to learn to use a scientific calculator if you are not used to it already. That is also not hard. Under the question paper, if we carefully evaluate the terms and conditions, which is in the page 1 of the paper, it says that the calculator has to be a non-programmable one. I brought down 2 examples to show you. Now, for example, now this Texas Instrument BA2 Plus calculator is a programmable calculator. What you mean by a programmable calculator is that this calculator has certain equations like the present value, the yield of a treasury bond embedded in the calculator's memory. So as long as you know how to or where to enter the values, you can easily get the answer to any question simply. But under this examination, that is not the type of calculator which we will be using, but a simple scientific calculator like I'm showing here. So the model, what I want to show you is an example of Casio FX991. There are many models like ES, MS, so on and so forth. So if you don't have one of these calculators, I'd like to recommend you go and buy one. Because if you try to delay till the close of the examination while using a different calculator or your mobile phone, you might not be really comfortable in the examination. The last point which I want to touch upon is how do we answer the questions in this paper. This is not a theoretical paper like economics or policy related paper, rather a calculation oriented paper. So you are invited to write precise, direct answers with examples wherever possible. And also, like in any mathematics stream, it is very important to refer to your workings also. For example, you may have done the calculations correctly, but unfortunately, if the examiner is keen to know how you have done the calculations, it's a good practice to always refer to the working on a next page, adjoining page, or maybe an annex page, that doesn't matter. But as long as you have the correct reference so that the examiner can once again go and check whether you have done the calculations in a correct way. So that is the structure of the paper which we want to discuss. Are we clear so far? Am I still audible to everybody? Right, great. Okay. That's about the structure, the recommended subject coverage, and the IBSL program itself. Let's start today's session by discussing this question, or rather I'll call it an example. Imagine now we have a classroom with 75 students. Now these question marks that are put on are assumed to be the places where those 75 students are seated, all right? We want to get an assessment of the students' mathematical knowledge before we move ahead with this program. Now, how am I going to do this? One easiest way would be I can ask everybody to, okay, from number 1, 2, 3, and 4, and so on and so forth, uh, to rise and tell your marks which you have gained for your ordinary level examination for me to just to get an understanding. But it may be time consuming and an embarrassing exercise. Some people might not like to share their marks, and some will be very proud to share. So the sometimes the answers that I'm getting might not be really true and fair, right? And it might be time consuming also. Now imagine instead of 75 students, let's say there are 1,000 students. How long will it take to gather all this data? Maybe 10, 15, or even a half an hour. What if I select 1/3 of the population? That is, I choose 25 students by taking the first, fourth, seventh, 10th, and so on and so forth until the 73rd student, which will give me a subset of the entire 75 students. Right? And then I will give them a blank sheet like this, which will have 25 blocks. This is a 5 by 5 block. And I will invite them to fill their ordinary level mathematics grade in a random way. It doesn't have to be the first person to fill the first box. Rather, he can maybe select the 16th box, so on and so forth. And eventually, we will be getting something like this. So by looking at this table of 25 grades, will I be able to derive something easily? On the face value of it, I see some C's, I see some A's and B's. I don't know which one is the maximum. It's a bit uncomfortable, isn't it? Let's try to summarize the findings on that 5 by 5 grid into things like what we see here. I can count the numbers from here and get the totals of the number of A's, B's, and C's out of this 25. Now, how do you feel it? It's a bit more descriptive, isn't it? I see out of this 25 students that I'm focusing, we have 9 students who have got A's for their O levels, 12 B's, and 4 C's. What about the next one? 36%, 48%, and 16%. It gives even more explanatory values. Isn't that so? Out of the 100% students, we have 36% A students and 48% B students, who I can derive in different ways. I could say there are more than 84% students who have obtained B or above. What if we graphically try to explain it? On the bottom of it, you see the pie charts and the bar charts will give you even easier representation. Focus on this grid of 75 students to the end results which you see here. Now, ladies and gentlemen, this is what we want to discuss under this subject, so-called statistics. Right? With an example, let's start our first session of this lecture series, which is on the Introduction to Data Collection Methods. We are going to discuss the data and information, types of data, sources of data, population and sample and sampling methods. We shall be effectively discussing this entire set of things in 2 lectures. The first lecture will be focusing on these subject areas: data and information, types, sources, population and sampling, and some sampling methods. And then we'll come to the past paper questions, which they are testing this knowledge under this very first area, right? Now, ladies and gentlemen, we just discussed an example of 75 students, and we got to know that 36% of the students are having A's, 48% having B's, and 16% C's. You see, we if you just merely want to get all the data collected and try to get an understanding of the entire 75 students, it might take a little time. And sometimes the data that we are collecting might be not really fair and true. So statistics is a science or a study which we can use the techniques in collecting data on different subject matters, organize them, present them, analyze them, and derive conclusions out of the collected data. That is exactly the example which we discussed a moment ago, isn't that so? So we could see these four sections, or rather the steps, as the most essential steps that we can see in any statistical study. The first step is to collect the data. Second step, organize them and present them. Third step, we analyze the data. Finally, we derive into conclusions. These are some of the uses and characteristics of statistics. We are presenting the facts and data in an orderly manner. Sometimes if you just take those 75 students in a bulk, you might not really get a sense of what we are studying here. Rather, we categorically selected 25%, 25, that is 1/3, and then got some information on what they're presenting, and we organized into an easy way to understand the characteristics that we are focusing, that is the mathematical knowledge, right? The second point, we are trying to simplify the complex set of data in a meaningful manner. In the modern context, we have buzzwords like the big data. For example, your browsing patterns, or your social behavior, or your travel patterns, or your eating habits. So those are very large and complex number of data which will not be meaningful if we just look at them in a very raw form. So statistics is used to simplify those complex data, the big data, and convert it to a very meaningful manner to anybody to understand. Third point, it is a mechanism of comparison. Say, we have that class of 75 students, and we have an adjoining class also with another 75 students. We could use the study that we conducted and conduct the similar study on the other class and get results and compare which class is having better mathematical knowledge. So by using the mechanisms of statistics, we could do easy comparisons. Fourth one, a tool that can be used to analyze human experience in a scientific manner. Sometimes, down the line also we'll be discussing this in detail, sometimes we may observe certain expressions or passions or biasnesses or choices or appetites, which we can't merely explain it in an orderly manner. But if we use statistics, gather such data, organize them and present them, we can idealize the human experience in a scientific manner and present them. Can be very helpful in deriving policies, of course. For example, let's say we want to determine which districts in Sri Lanka is having severe shortages of fertilizer at the moment. So we could derive a small sample study in each of these districts and determine by talking to the farmers and doing some surveys and interviews, we could determine on the policy level to, let's say, for the district of Ampara, we need to give more fertilizer. For the district of Colombo, there's sufficient fertilizer. So those kind of policies will also be derived back by the support of statistical data. Finally, it is a tool which is helpful in defining the size or gravity of an event. You might encounter some of the statements saying that it's an earthquake of 5.5 magnitude, it's an earthquake of 7.9 magnitude. So that scale of Richter units is being defined in a way to define the size of an earthquake in an equally comparable manner. Similarly, statistics, the tools that we are using, is been helping mathematicians to show the nature or the gravity of an event in a very concise manner. For example, let's say I take 3 students and conduct that sample and imagine, let's say all of them are having 3 A's, and I would say in my graph, it's a population of 100% A's. But what if the other person conducts a similar test on 30 students and he finds some more scattered data like A's, B's, C's, and even failures? So that event versus my event is having two different gravities or impacts. Whereas my event is having less number of data, while the other 30 example is having more and more fruitful data. These are some of the characteristics which we want to discuss. There are some more. It can help decision making under uncertainty. Sometimes we do not know all the variables of a given situation. So we have to make some assumptions, we have to put some errors aside and derive our equations and logics accordingly. It can help you to forecast the value of variable using the past data. We call it sometimes extrapolating. We have a set of historical data, and using the statistical models and mathematical models, we can derive equations and forecast the next value, what is it is going to be. It shall assist in identifying the relationship between variables. It's also very important. We are discussing this under linear programming, multivariate, and many more sections. So there are few variables of a given matter which will be moving hand in hand. So by observing the set of data and trying to derive an equation and try to understand it, we could see the relationship between individual variables. It will analyze a sample and assist you to understand the characteristics of an entire population using relevant model. That is exactly what we discussed at the beginning of the class. We analyze 25 students' marks and we derive and come to conclusions of the entire 75 students. These are some of the instances or areas which we can see heavy usage of statistics in industries and businesses. When we want to establish a company or an industry, there are many statistical studies, pilot studies, sample studies, feasibility studies has to be conducted. For example, let's say we want to establish a apparel company in a particular area. So the owners of the company will invite statisticians and the research team to go and conduct a sample study among the population of that area to see whether they would like to get more job opportunities, or whether they will find it disturbing, or whether they would like to sell some of their lands for the factories to be built up. So when especially we are trying to establish a company or a new industry, we have to use many and multiple statistical models to finally make a decision. When we're producing a good or a service, statistics is again heavily used. Especially we are looking at the consumer appetite and the demand for a particular good or a service. Say for example, do we see many ice cream sales in December? No, isn't that so? This December tend to be typically a bit of a non-warm month. We don't see much people going out and eating ice creams in December. So if we conduct a statistical survey of ice cream sales on a particular area in January to December, you might find that producing more ice cream in December will make the company into a bit of a disadvantageous position. In preparing a production plan, sometimes when companies are preparing their outputs, they have to be very mindful of the inputs that they are putting up to the process. What are those inputs? Can be man, material, time, premises, a lot of resources. So there can be bottleneck resources, there can be leading resources, and many more. So you, as the decision maker, will have to use some of the models and design your plan carefully. Otherwise, what will happen is that some places you will see stocks being piling up, and some places you might see people are idling. Sales and marketing service, production controls, human resource planning. All these are similar instances where we could see statistics is being heavily used. For example, if you take human resource planning, let's say we want to get 50 new trainees for an engineering division. You could advertise and maybe you would find 500 or 1000 different applications, filter them out using some set of criteria, statistical criteria also. Give them an examination, again use statistics, uh, grade them, mark them, conduct some interviews and examinations. Again, interviews is a type of statistical tool that we are using. And finally, decide which 50 out of the examination completed candidates to be taken into consideration. Financial planning and investment decision making is some of the most statistics oriented areas which we could see in any country or any uh, domain which is mainly related to investments and finance. Why? Because in these areas, unlike much of the tangible things which we discuss like sales and production, in these areas everything boils down to numbers, stock prices, uh, balance sheets, income statements, accounts. So this is where you might be invited to looking to averages, uh, and then come to like various time series data and come to conclusions on various financial models where everything will be backed by statistics. We discuss all the good things about statistics, the characteristics, uh, usages in different industries. However, there are areas which you could see uh, statistics can be also misrepresented and misinterpreting what we want to elaborate. Let's discuss some of these examples. See, look at the first one. Misleading or elaborating of analyzed data. In this example, we are mentioning that 66% of the students have been selected for their higher education from a school. Now, if you just read that sentence and stop it there, you might say, okay, there may be hundreds and 200s of students in that school, and 66% are passing their examination and going for their higher education. But look at the last part. When there were only 2 students have been selected out of 3 students from the school. That means in their population of higher education eligibility examination, there are only 3 students who are sitting for that examination. And out of those 3 students, 2 has completed the examination and passed to the next level. But if we use that percentage mark and just mention that without saying anything about the population of only 3 students, we are misleading the listener or the audience. Look at the second one. Using non-matching data for comparison purposes. In this given example, we are saying after comparing the profit figures of company A to be 100,000 rupees and company B 150,000 rupees and deriving, now if you just look at those 2 numbers, it says company A's profit, let's say profit after tax, is 100,000 rupees and company B is 50% higher, isn't that so? 150,000. And if we just look into those 2 facts and try to derive that company A is less profitable than company B without comparing the nature, size, and the level of operations, it is also misleading and misrepresentation of statistics. Sometimes A may be a company of a size of a small grocery store, while company B may be a large retail chain like Keels or Cargills for that example. For a given month or a quarter, their profits may be low due to various reasons. Maybe they have spent more on capital expenditure, maybe they have had the heavy marketing expenditure on one of the campaigns. Whereas company A may be very small in size. They may have not had any of these, while they have generated a profit of only 100,000 after their monthly operation. So see, we can't merely compare one fact and interpret and come to final conclusion saying that A is better than B without comparing the surrounding facts. Some more examples. Look at this one. Interpreting results based on a biased sample. Look at the example. Predicting the win of a candidate of an election based on a sample selected to be biased voting to the said candidate. Let's say in this example, Now there are agencies who are conducting research and surveys near to elections. Even in our country. There are many other developed countries who are highly paid firms conducting such surveys because it's very important for the politicians to predict the next move in their career. But what if this researcher or the said company goes to one particular area where they have some predetermined knowledge of that voting pattern of that area based on their historical data, and they knows that that particular area is being biased to be voting to the said party or the said candidate. And if we just collect data from that area and come back and say, all right, we collected some data and we could see that 70% candidate X will win and only 30% candidate Y will win. Is that a fair statement? That might not really be. Uh, if they want to really interpret the true picture of this given example, they will have to select based on a scientific matter different samples and go and collect data prior to come to the conclusion. If that is the case across the country, then that's fine. But uh, for sure, if they conduct this testing in different other areas, they will find different results, and we could take a simple average to see what is the voting pattern of this country. Look at the other example. Recommending merely based on an inadequate number of observations. The example that we are discussing is recommending a medicine, stating that 80% of the doctors have recommended it, where only 4 out of 5 selected doctors have recommended the said medicine. Similar to the very first example that we discussed on the higher education, isn't that so? So the population is only 5 doctors. 4 doctors out of those 5 is recommending this particular medicine. But we may brand it saying 80% of the doctors are saying that this is good for the illness that we are focusing. Is that a fair statement? It might not be, isn't that so? So, what do we want to do to enhance this situation? Talk to more doctors. Make the 5 doctors 50 or 60. Or if you can get maybe hundreds and hundreds of doctors, you might get the true picture on the recommendation. Right? Right. So we discussed extensively on what is statistics and the advantages, characteristics of using statistics in our day-to-day life as well as in industry, as well as some of the misrepresentations or misinterpretations of statistics intentionally or unintentionally. Let's dive down into statistics and try to understand the different components what will be used, what we'll be using to derive different models and come to conclusions. Now, the stuff that we're learning from now onwards will be the building block that you will be gaining to derive your end results in any examination question also. The very first thing which we want to discuss is data and information. This is something which we discuss extensively in many different subjects. Data are raw and unorganized matters that need to be processed to make it informative. Uh, Now remember that 5 by 5 grid we discussed at the beginning of the class on that example. That 5 by 5 grid of 25 students O-level marks are raw data. Is that information? No, it's not. It's just merely presenting in a box of raw form. On the face value of it, we have the individual mark or the qualitative characteristics of that matter that we are focusing. But the set of data after being processed, I showed you some of the tables and the graphs, pie charts, bar charts. Now that is where the raw data is being subjected to some form of a process to convert it into a meaningful way where we call it information. It's very important to understand the distinction between data and information. Sometimes people tend to mislead, be misled by the fact that they have been presented with. Statistical data are inputs to statistics that can be measured, quantified, counted, or classified for decision-making purposes. Now, the one we discuss under data, we are giving it a adjective also in the statistical data to be more precisely be measured or to be taken into consideration of the jargon of statistics. Finally, we want to discuss the term statistics itself. It is a methodology which has been developed for interpreting and decision making for the from the collected data. Now, from the beginning of the class until now, we merely only discuss the exact same thing. We collect some data, we process it, and then derive it into we derive into conclusions using the processed data, which we call as information. Now, those are the jargon under the very basic area of statistics. Let's look into these examples. The first example, we want to identify whether this is a data or information, right? The first example says numbers of rainfall is given for 10 days are as follows. First day 5 millimeters, second day no rain 0 millimeter, third day also no rain 0 millimeter, third day seems to be a heavily raining day 25 millimeter, 30 millimeter, so on and so forth until 0 millimeter. Let's assume we have 10 data points here. Second point which we want to discuss is the average rainfall in Colombo district for year 2020 January is given as 15 millimeter. Ladies and gentlemen, when you look at the two statements, the first statement is defining a set of raw data. Is that information? You might tend to misunderstand that, okay, that is also information, but that is not the case. It is merely one fact that has been extracted by using some measurement device or some measuring criteria. 5 millimeter, 0 millimeter. That's just a data point. So how do you derive that 15 millimeter is by dividing those 10 values by 10 and getting the answer of 15 millimeter. Now that is information. It says average rainfall in Colombo. So does that mean that every day whether it will have 15 millimeter? No. You might find 75 millimeter in one day and 0 millimeter in a couple of days. But it will average out to 15 millimeter. That is information. That's the distinction between data and information. Let's move a little bit further. Now the data which we discussed a moment ago can be segregated into many different ways. There's no one, I would say, one holistic way to define the data into characteristics and say this is the only way. No, this is what we're discussing under here. Qualitative and quantitative is the most frequently used method to categorize the data which we can see in our day-to-day life. Be mindful, there are many other ways also to categorize data. The very first one, the very first type rather, we call it qualitative data. That means we are extracting some characteristics or a quality which might be a bit tricky to measure in a quantifiable numerical manner. So the other type is the opposite. Quantitative means, unlike a quality, you tend to measure it, you tend to gather it, but in a numerical way. That's a broader two branches which we can see under this study, qualitative data and quantitative data. So the qualitative data, we could see that it further goes down to two different branches. The first one is normal data, and then, sorry, there's a small typo here, ladies and gentlemen, this has to be nominal data. I'll correct it. The second one is ordinal data, nominal data and ordinal data. Under the quantitative branch, further it can be categorized into discrete data and continuous data. Let's look into one by one of these types. Now these are examiners' favorite areas to question your knowledge, and we need to understand the definitions in much more precise manner. I repeat, there's a small typo here. Under the types of data, qualitative data, the first one, it should be nominal data, not normal data, right? Right. Now we are under the branch of qualitative data, nominal versus ordinal. As given here, these are non-numerical categorical data that fits into different baskets or classes or types or segments. The nominal data which we discussed a moment ago are data which can be categorized without providing a numerical value. A good example will be gender, male or female. On the other hand, ordinal data is also qualitative, very much similar to nominal data, but the difference is that is data which follows a natural order and can commonly be represented using tools such as bar charts. Now let's try to get the perfect understanding of the distinction between nominal and ordinal. Nominal is merely you try to categorize some characteristic of a particular data, try to just basket them into some classes. Males on one side, females on the other side. Sri Lankans on one side, Indians on the other side, likewise. But the ordinal data is also qualitative, but it can be ordered and presented it in some sort of a formal manner. One good example is that in mathematics and statistics, we call sometimes a Likert scale. That means, we'll discuss an example. You have been asked to go to one of the fast food chains and enjoy your meal. And afterwards, you get an SMS saying, if you're satisfied with the food, please rate our quality as per your understanding from 1 to 5. So you have been given 5 choices, 1, 2, 3, 4, and 5. Is that a quantitative data? No. A data to be quantitative, it has to be having some value, 52 kilos, 120 centimeters, likewise. So what we are gathering here is a quality. The quality is the tastiness or the appropriateness of the food for the consumption. But for that, to have a broad understanding, we have been invited to categorize our experience into those smaller baskets. If I'm not really satisfied with the food, I would categorize it as 1. If I'm extremely satisfied, I'm very happy, I'll categorize it as 5. So you gather that data for thousands of customers, and then you could nicely put up a small bar chart and see whether for that particular dish or for that particular meal, whether people really like it or not. It's also qualitative data we gathered. But unlike the nominal data of merely being categorizing and just putting it aside, we could orderly represent the behavior or the appetite of the survey that we conducted. Another good example would be the level of pain. Let's say now there's a patient coming to a doctor, and the doctor cannot really, can the doctor measure the patient on pain? Of course, you might see the patient is very uncomfortable, but let's say the doctor needs to assess how painful you are feeling. So you might give another scale. I'm feeling less pain, I'm feeling some greater pain, severe pain, and extremely painful. Patient will take, okay, I'm feeling extremely painful now. Likewise, the ordinal data, every time, when this has to be very carefully understood, the distinction between nominal and ordinal. Ordinal, all the time, we try to organize and categorize the data that we are presenting. Unlike the nominal, where just we put things into baskets, right? The other branch which we discuss under this slide, that is the data that can be classified for the quantitative aspects, right? The quantitative data are numerical data which has a value in it. That is, for example, how much, how often, how many. So the value that we are collecting, unlike the qualitative data, will have a number or a value that can be measured using some scale or anything that will help us to measure things. The first branch is discrete data. Discrete data are data which can be take only discrete values, such as number of students in a classroom. Can we have 57 and a half students in a classroom? No. We'll either have 57 students or 58 students. Let's say number of aeroplanes that has been landed on a given day in Bandar Naik International Airport, can that have a decimal or fractional values? It can't. It will always have a value of 1, 2, 3, so on and so forth. Or some negative values also, -1, -2, doesn't matter. Unlike discrete data, the other branch what we can observe are the continuous data. That means data which have infinite number of probable values in a given specific range, such as room temperature. Now the example which we discuss under the discrete data, number of students in a given classroom, cannot have a fractional value. But what about the temperature? Can it only have 22 degrees and 23 degrees? No. It goes into more finite numbers like 23.1, 23.2. Will it stop at the first decimal? It can even, if your measurement device is strong enough, it can even go to the next level, 22.12, 22.121, 22.123, so on and so forth. So the continuous data, unlike the discrete data, will have multiple values which will be stemming from 0 to maybe infinity, positive and negative both sides. So let's summarize the discussion once again. We could see the data can be classified into two broader branches of qualitative and quantitative. And under the qualitative, we could observe there are nominal data and ordinal data on one side, and on the other side, we could see quantitative or numerical data, which can either take the form of continuous numbers or discrete numbers. It's very easy. Let's discuss some of these examples. Try to, while we are going through the class, try to resolve it in your own self. Classify the following data into respective data types as discussed above. That means you have to first recognize whether it's a qualitative or quantitative, and then cluster into the 4 baskets which we discussed. Let's look at the first one. Numbers between 23 and 24. Numbers between 23 and 24. This question, it doesn't really say integers or the whole numbers or fractional. It does say number. It just say numbers between 23 and 24. So we can assume that this is a type of a quantitative data. And is it discrete or continuous? It seems to be continuous. 23 and 24. There are many numbers. Look at the second one. Types of vehicles registered in the Department of Motor Vehicles. Now, in the Department of Motor Vehicles, you may see different types of vehicles like motor cars, motor vans, trishaws, motor bicycles, land vehicles, so on and so forth. Types of vehicles. Does it have some sort of an orderly manner, like a Likert scale or what the pen example what we discussed? No, it's merely baskets. So this seems to be a qualitative data which comes under the nominal section. Third one, number of flights arrived in an airport on a given day. We discussed this a moment ago. Can't be 53 and a half, right? It has to be either 53 or 54. So this seems to be a quantitative data and a discrete type. Temperature of a city on given 7 days. Temperature. We discussed this. Can it have only whole numbers? No, it can go, if your measuring device is strong enough, it can go to n number of decimal points. So it's quantitative and continuous. Last one, daily prices of a given stock in the Colombo Stock Exchange. Bit tricky. Some of you might not know. We have a smallest ticker, that means the smallest size that the prices can go as 10 cents. So you can have 23.10, 23.20, 23.30 likewise. You can't have any fractional values in between 23.10 and 23.20. So again, quantitative data, but discrete data. This is a tricky example. You might not code this at the exam. However, if you just been asked to describe the daily prices, uh, I'm being very categorical saying that Colombo Stock Exchange, under the context, it is discrete. But on theoretical ground, if the stock prices have more decimal numbers and let's say multiple more points that is being measured and presented to the audience, it can be classified as continuous also. So in this example, you can't really give a straightforward answer. Under the context, we could see it's discrete, but under the other circumstances, we have to carefully look what those prices are before answering, right? There are some other segregations also which we could categorize data into different models. Now we discuss the qualitative, quantitative method and try to basket them under different ways. But these are some of the other sections, other names that we can observe in the statistical jargon, which we could gather and classify data cross-sectional. For example, from each section, we collect some data. Time series, January, February, March, April, some information is being gathered. Pool data, it's a hybrid method of cross-sectional and time series. Panel data, again another advanced method of pooled data, which has same observation measured again and again for n number of times. Now these, although we discuss this as types of data, these are more towards data being tried to convert it into different samples for our further studies. Some of these names we shall be discussing if we see some of these areas being tested in the examination, but for the very recent examinations, we could only see that qualitative, quantitative understanding and the types of nominal to ordinal and other two methods of discrete and continuous being heavily tested with examples and with the underlying assumption being tested heavily, right? Okay. So there are the data which we discussed again and again can be stemming or can be emerging or can be born out of multiple or different sources. In statistics, those data sources can be broadly we classify as either primary data sources or secondary data sources. The main difference, it's a bit easy to understand also, the main difference between the primary data and secondary data is where the primary data is gathered or collected for the purpose of the study on the time right now. Whereas the secondary data, for a particular study, somebody has already collected it and published it and available for us to borrow and use it for our analysis. If we just look into the formal explanation, primary data, these are data which should be cultivated or gathered from the scratch, from a primary source, such as raw data collected from studies. Now that study which we discussed in the beginning of the class of 75 students, it's a primary data gathering of raw data. How about secondary data? It says these data already exist in some form, some from where they are already available, such as reports and publication. Now, for example, if you look at things like central bank annual reports or daily prices of the Colombo Stock Exchange, which we discussed a moment ago. Now, those are already available. Somebody has already collected it and maybe tabulated it or maybe converted it into some form of easily understandable manner and being disseminated for your availability. Now there are some examples which we can discuss on primary data and secondary data. We'll take a moment and try to discuss them those matters here. Primary data are very much cumbersome to gather. For example, that 75 students example, we ourselves have to spend time, put up our resources, then collect. On the other hand, secondary data, it might not be the case. It's already available for us to. Sometimes it's free for us to just refer a website or a paper or a publication and get our hands on. How about the time consumingness? Primary data, it is very time consuming to gather, while the secondary data is already available. Sometimes primary data gathering is, it can be a costly method, while secondary data, as we discussed a moment ago, it can be even free. How about the reliability, primary versus secondary? Now the secondary data, it's not you who collected that data, isn't that so? Somebody else. So when we discuss the fact on reliability, sometimes we might tend to see primary data is more reliable than secondary data because we ourselves, our researchers or ourselves will go and collect the data by hand in the first instance. Now, those are some of the advantages and disadvantages in primary and secondary data. So one would say, okay, although it's time consuming and although it's costly, we should always use primary data, and secondary data seems to be, somebody else has collected it. It's just we don't know what those sources are. We don't know the data collection method. We don't know whether they have done a fair job or whether they have just randomly put up some numbers. However, there are instances where you might find using primary and secondary are very much unavoidable or essential in our day-to-day life. For instance, let's say you want to do a PhD. You might depend on certain level of secondary data. However, more or less, you might be interested to derive a model. We discussed in the very beginning, like you come up with a hypothesis, and to prove that hypothesis, you might use a lot of raw data gathered to say whether that hypothesis is true or otherwise. But on the other hand, let's say we want to compare the financial position and performance of two companies, company A and company B. Let's say two banks, for instance, a state bank and a commercial bank. Now, what can we do? Can we go to the bank ourselves and go to the accounts department and say, okay, I'm conducting a study, can I have your annual reports? Can I have your access to your account level? It might be a bit uncomfortable, isn't it? So on that instance, there may be already published annual accounts or annual statements of those two banks under consideration. So just a matter of accessing those data on their website, downloading, coming to the same page of financial position and performance, categorical the income statement and the balance sheet, and compare and contrast the data and derive your conclusion accordingly. Maybe 2, 3, and 10 number of banks. You could do the same. So that is where you have to depend on secondary data. Like I explained before, you might not have the privilege to go and get the data on primary sources as and when necessary. And sometimes there can be even difficulties in gathering data. Now, in Sri Lanka, if we want to gather some statistical data, you may still have the accessibility to go and collect. But if we want to gather, let's say, mathematical knowledge of students of age 20 across the globe, can we go and travel and go to India, Pakistan, and USA and gather the ordinary level or equivalent examination grades? It's going to be a bit uncomfortable, isn't that so? So accessibility has also impeded trying to limit ourselves into primary and secondary data. Geographical boundaries has given some limitations also. So those are some of the merits and demerits of using primary data and secondary data. So a moment. Yeah. All right. Now, can you distinguish between the primary and secondary data on this given example? Look at the first one. Daily stock returns of a given stock listed in the Colombo Stock Exchange. Once again, daily stock returns of a given stock listed in the Colombo Stock Exchange. Stock return as in you might see the price differential as well as dividends and other corporate actions being given to the shareholders will derive returns of a particular stock. So those are daily stock returns, that means published by the Colombo Stock Exchange. Is it primary? Is it that we go and collect the data? No. Published by somebody else? Yes, published by Colombo Stock Exchange. So this seems to be a secondary data. Look at the second one. Inflation data published by Department of Census and Statistics. Published by Department of Census and Statistics. Again, secondary data. Look at the third one. Treasury bond yields received from a money broker. For those who are not very comfortable with the jargon, let me explain. There are parties called money brokers in this country where they tend to quote buy side and the sell side of particular treasury bonds and treasury bills to other market participants on a continuous basis. So those data points can change from time to time from money broker to another broker. Let's say you talk to first money broker, he might say 7% and 8%, certain different numbers, and then you call the second money broker, he will say 7.1% and 8.2%. Now, look at that statement. Treasury bond yields received from a money broker. That means we tend to be acquiring it. We tend to be going after and collecting it from a primary source. So the information is fresh. It's collected right now. So that seems to be a good example of primary data. Last one, data published in the annual report of the central bank. Very easy. Secondary data. So if we look at some more primary examples, all the time that we can observe primary data is where we get our hands on and collecting some information. Say you're conducting a research, primary data. You're conducting a survey, primary data. But if you are trying to get your hands on data or information which is already collected, that is secondary data. Simple as that. But be mindful, ladies and gentlemen, now these are some of the areas that examiner is testing your knowledge. Now you need to say, for example, if they ask a question on distinguish between primary and secondary data, you can't merely say that primary is we just go and collect, secondary is we use from somebody else's. Rather, we have to be a bit descriptive and give point by point with some examples for you to score some marks here, right? Okay, we're moving a little faster. Coming to the last sections on this particular lecture, where we want to discuss on the population and sample. Ladies and gentlemen, we discussed in the beginning of 75 students in that class, and I chose 25 students. Now, why did I choose 25 students? Because I decided, okay, 25 seems to be a good number for me to get an understanding on the rest of the, sorry, not 25%, 25 students seems to be a good set of people for me to get the understanding on the other 50 students in this classroom. Now, indirectly, I applied the concept of population and samples in the very beginning of the class without your knowledge. Population is the entire set of data or individual items under consideration. For example, the population can be all registered doctors with the Ministry of Health, all registered students in the IBSL, all registered ordinary level examination students for year 2020. The entire set, the complete set. We denote it by capital N in our statistical jargon. On the other hand, sample is a smaller one. We denote it by simple n. It is It is a part extracted from the population which is assumed to be representing the entire population on a non-biased manner. Look at that statement carefully. It is a part extracted from the population which is assumed. Now, can we guarantee? No, we cannot. Can we say that those 25 students in our class example is representing the entire 75 student in an equal way? It's difficult to say, but we assume it to be representing the entire population in a non-biased manner. Can you remember in the very first couple of examples we discussed being going for a biased area and collecting some data on the voting pattern for a particular candidate? That doesn't have to be the method of choosing a good sample. It has to be non-biased. That means we have to do everything in our power to make sure the sample that we are collecting is going to represent the entire population in an equal manner. Can we guarantee it? We cannot. The last point which we want to discuss is that it is always easy to study the sample due to the small scale. Can the sample be the bigger one and the population be the small? No. Population is the bigger box always. Sample is a smaller circle that we take to study. Under the second or the next week's lecture, we'll be discussing extensively on the sampling methods. We'll be briefly touching upon the concept of sampling and population under today's lecture. Broadly, now we discuss of selecting that 25 students out of the 75 students using, if you could recall my example, I choose the first student, then I choose the fourth student, then I choose the seventh student, so on and so forth. One and then two intervals, then the other one, then two intervals, the other one, so on and so forth. Now, it seems to be some sort of a scientific method, isn't that so? So, I could do another method similar to first row. I'll invite the first row, first person, second row, second person, third row, third person, fourth row, fourth person. Similarly, I could derive multiple ways to choose my 25 students. Can somebody think that how many ways can I select 25 students out of 75? We could use permutations and combinations and identify there can be n number of ways for us to determine, and even further, we can use different other characteristics also to select those 25 students. For example, I can ask, okay, people from Colombo district come to one side, and I could select two people from there. People from Gambha district come to the other side, I could select three people. Likewise, also I can build up my samples. So, building samples from a total set of population is what we are going to discuss as sampling methods. So the sampling methods that we can broadly see can be classified into two broader areas. We call them probabilistic sampling and non-probabilistic sampling. Let's read the text also. The main idea of sampling is to study the nature of the entire population without examining the individual items in the population. Now, if we have been given a choice to study the entire population versus choose a sample, provided other things being equal, the effort and time that is consuming and the cost and everything is similar, we should always go and study the complete population. Why we are choosing the sample is merely because of the easiness of accessing into data and deriving and extrapolating our assumptions to the entire population. That's why it says without examining the individual items in the population. So that is our intention. So the sampling that we could see in the statistical world can have these two branches under their descriptions. So this is a section which will be stopping the first lecture. However, let's have a brief look into what these sampling methods are. Coming to the definition, the probabilistic sampling and non-probabilistic sampling. from the word itself, it says probabilistic sampling tries to identify the sample based on some form of a methodology which will have a probability component in it, right? Non-probabilistic sampling will not necessarily look into giving some equal weightage to the items to be selected into the sample that we are selecting. Now these names which you see on the right hand side under the probabilistic sampling and non-probabilistic sampling are multiple methods which we could use to select from entire population to our sample. Let's have a brief look at individual items. Uh, Now the probabilistic sampling, simple random, is what we did a moment ago. Randomly, by using some method, we choose students. I just point my finger at different students and I collect 25 samples. We can name it as simple random. Systematic, what I did. Actually, what I did could be justified under the systematic category. I define some sort of formula or a methodology. Stratified and cluster are where I cluster the students. Like I said before, I put the people who are coming from the Colombo district to one side of the classroom, Gampa district the other side, Kalatara district the other side, and then from those clusters, I select different number of people to build my 25 sample. Now, these are where I give equal opportunity for the entire population to be get selected for my sample. On the non-probabilistic sampling, there is no equal opportunity. That's the main difference. And the convenience, like the word says, I could choose my sample based on the convenience. I could ask the first 25 students in this class in the easiest accessible rows to come and write my write your marks in that 5 by 5 quadrant and give me the data. Judgment, purposely, that means purposely I select based on my judgment. Okay, that third row seems to be a person who are having some good marks in the mathematics. The fifth row might also have. So I, based on my judgment, I select some people from the particular rows. Quota, I give different quotas similar to that stratified and cluster. Only difference is that unlike the equal opportunity being given to all the baskets, I define the quota myself. Snowball is also another sampling method. I could see that I'll ask the same question from one person. I'll ask them to introduce me to two more persons. From those two more persons, I'll get five more responses. So it's like a snowball. From the first to the second to the third, I invite my population itself to become my sample. So, ladies and gentlemen, now those are different sampling methods which we'll be discussing extensively in our second lecture, where we'll be discussing different examples and we'll be going through some of the workings for us to get ourselves understanding on the sampling methods, right? Right. So I'll take a pause here and from the questions, yeah. So from the theory that we discussed up until now, if you have any questions, we'll spend around 5 to 10 minutes, try to get it resolved. You can switch on your microphones and ask, or on the other hand, you can use the chat window also to raise up any questions. And if there are nothing to be discussed, we'll move on to the second segment, that is we are discussing the past paper questions. So here, what we're trying to do here is to classify these data types as per the qualitative, quantitative, and under the nominal, ordinal, or discrete and continuous data, right? Now, for us to get an understanding of the discreteness and the continuousness of a particular data point is that if for a certainly measured quantitative aspect, if the number of decimal places or the fractions can go up to even more smaller values up until the measuring point is over, that is where the continuous data is visible. For example, the room temperature or the body temperature, or the length of a particular table, you could say it's 27 centimeters. But if your measuring device is even sharper, one could say 27.1 centimeter. And even sharper, 27.123. Similarly, it can go up to infinite number of decimal points. Can you say the measure of the table is 27.173 centimeters and stop there? You cannot, because it can even be measured if you could have the measurability. But under the example which we discuss here, it's a bit of a tricky example. I just put it deliberately for you to get yourself to understand the daily prices for a given stock in the Colombo Stock Exchange. Now, in our Colombo Stock Exchange, the minimum price point is 10 cents. Now, for a particular stock, you may observe a price point of 23.10. Again, 23.20. Can you observe a price point between 23.10 and 20? You cannot. Why? There's a rule in Colombo Stock Exchange. You cannot have a price point lower than 10 cents. So it seems to be a continuous data. However, it could be argued that it seems to be a discrete data. Is why the measurability, the quantitativeness of the value, the price is the measurable variable that we are measuring here, right? It stopped at one point by a rule defined by the data deriving agency, that is a Colombo Stock Exchange. So that is why you could see, unlike a room temperature or a length of a table, you might classify that as discrete data. Good question. You're welcome. Okay, last half an hour, we'll spend ourselves. I'll switch on to my other presentation for us to get a bit of an understanding on the question paper and where the areas are being tested again and again. Now, the first question, the compulsory question, where you will see MCQs and short-ended answers. Sometimes one or two questions could be tested on sources, sampling methods, types of data, primary and secondary, on and off in the examinations. We will, throughout the course of study, we will try to focus on at least 10 different past papers from year 2019 up until year 2015, so on and so forth. And if the time permits, we'll try to find even more deeper past papers and study some more areas. But we have to be a bit mindful also, because these subject matters, the content is being changing continuously for the purpose of improvement by the IBSL time to time. So the most recent 5 years will give us ample opportunity to understand where the appetite of the examiner is being biased towards. So using our statistical jargon, we could say, we could focus what are the most frequently tested areas, what are the most frequently tested methods and subject matters under this examination papers. Having said that, from today's lecture and the next week lecture, we are covering the first section of this introduction to data collection methods, data information, types of data, sampling methods up until now. So once we study sampling methods also, we will be covering some petty marks in the first section. However, we might not really find a complete question like in cases like having the bond pricing or the portfolio returns, or on the other hand, linear regression. Unlike those areas, you might not really find one whole answer. So we discussed that this section can be tested under the compulsory question in a couple of MCQs and a couple of short-ended answers on and off. However, if you carefully analyze that, there's question number 8 in these papers, which seems to be asking the students to write some open-ended statements under a given subject matter. Similarly, in some of the other IBS papers also, you might tend to find that question number 8 always try to test the theoretical knowledge on different subject areas, which one student will be able to ascertain by following a module. So under question number 8, you might find some of the areas like this. Hope you can see the screen. The question paper that I'm discussing here is March 2016 paper, question number 8. Let's read the question now. Statistics involve in various types of data collected from various methods and sources. Compare and contrast the following items relating to statistical information. Now, ladies and gentlemen, you might find sub-question number 4 on normal distribution, positively skewed distribution is something which we'll be discussing in an upcoming lecture series. But look at the areas highlighted under red box. Qualitative data and quantitative data, primary and secondary data, sample and population. Now we have to be very careful. The moment we see, the moment we come to this question, sometimes you might tend to not use your 15 minutes effectively, and you may struggle a little bit at this point. And at the last moment, you will see this question and okay, sample and population. You write whatever you want. No, that's not what is being expected here. Read the question carefully. See, it's asking to compare and contrast the following items. The word compare and contrast says that you have to find similarities and differences of the given two words. If you focus on the examiner's suggested answers, now one might have a question, okay, for an open-ended question like this, what sort of length that you need to write to get the full marks? Now that's a question which a lot of students are asking again and again, because they tend to have some sort of a slight misunderstanding that the number of marks that one might get has a positive correlation to number of pages or number of points that you write in an examination. But let's take a pause. Let's do math here. Now for this question paper, how much time do we have? 3 hours, right? So 3 means 3 into 60, 180 minutes for a total of 5 questions. So that means close to 36 minutes for a question, right? Let me do the math if I'm wrong. We have 5 questions. And yeah, 3 into 60, 180, 180 divided by 5, that means 36 minutes you have to spend to write one of these answers. Now for you to explain these things, you might really find it okay, it seems to be a bit easy. Just write a couple of points under qualitative and quantitative, similarities and differences. Examiner will give marks, but that will not really work, because you have to be very tricky and use your time effectively. For instance, if you really try to answer this question and write it in the paper, unknowingly you might spend even 40 minutes to write, because at the examination you might your brain will be bombarded with knowledge. You won't, as in you studied extensively after the examination, and you are sitting it in a very pressured moment, and especially in a question like this, you have no guidance. For instance, if you look at another examination question on, let's say, linear programming, you have a lot of guidance in the question itself. It defines variable, it has values, so it's easy for you to understand where the question is trying to guide you. But merely if you have been asked to compare and contrast a sample and population, is an open-ended statement. You might write a lot of facts which you know, but might not really support the examiner's point of compare and contrast. So for the 36 minutes, so approximately within 9 minutes, you have to answer and finish one of these sections. So that's the time that you have to spend for a qualitative open-ended question like this. Having said that timing, again, students will have another question, whether are we to write essay type answers for an open-ended question like this, or point by point answers. What do you think? Do you think examiners having any preferences towards having essay types and points? I doubt it. I don't think that examiner will ever say, okay, give answers to these students who have write essays or bullet points. I would invite you to choose whatever makes your writing style comfortable. In my personal opinion, in my case, when I write for my examinations, I always tend to uh, put up the answer in the open-ended question with a title, small topic with an underline, then small introduction, and whatever I try to prove in bullet points, and whatever I try to disprove again in bullet points, and write a small conclusion also. If I have time, sometimes I tend to do some sort of cosmetics of painting the bullets also, which will give some sort of an eye comfort to the examiner. In contrast, if you, let's say, if you want to write a lot of jargon in your answer in a whole page without any spaces, without paragraph breaks, do you think examiners will find it really interesting to read it? Sometimes some examiners will find it a bit uh, uncomfortable for their eyes. And also, one important point is I assume that you have good handwriting also, because we have seen a lot of past, a lot of answer scripts of the students who are having extensively good knowledge in their numbers, in their calculations, but they're very poor in writing. So be mindful of that fact as well. So having said all these surrounding facts, I would invite you to, write a small answer for this qualitative and quantitative in your own words, and see and assess what sort of a time that you are spending here. Let's look into the answers. Qualitative data and quantitative data. So compare and contrast, as in you have to find similarities and differences. So both, you could say, are types of data which you collect to convert it to information and bring up some meaningful output to the decision maker. On the contrast side, you could say qualitative data tend to gather data on some of the aspects which doesn't have a quantifiable number or a value, whereas quantitative, on the other hand, which has a number or a value. Uh, and you can, importantly, like I discussed on my other slide set, you can put up many examples as you want. For example, if you write qualitative data and say gender or your geographical location versus quantitative data, measure of a particular shoe size or a weight of a person, examiner will understand that you have the extensive knowledge on the subject matter. So qualitative and quantitative data, merely we have to just discuss the uh, brief introduction, we do a comparison and find some, let's say, different aspects also, and put up some examples. Uh, that would suffice for a total of 5 marks. Look at the second one, primary and secondary data. So the examiner suggested answer says primary data are data collected specially for the purpose of a survey being conducted. On the other hand, secondary data are data which have already been collected elsewhere for some other purpose. So that brief introduction will be enough to start the answer, and then go and explain what sort of an example that you can come up with a primary data. For example, you're conducting your PhD and you want to build up a hypothesis and gather some data for you to test. That's a primary data. You are going to do some survey on stock prices or bond prices or consumer appetite. You collect some data from an agency that disseminates such data, secondary data. That would suffice for an answer of 5 marks. Again, for similarities, you could write both are data, both are collected, both are exemplary being used for different purposes, and both can be converted into information, both can be presented, there can be a lot of similarities. Look at the third one, sample and population, which is discussed a moment ago. Both are items or packs of items, baskets of items. Sample is the entire set of observations, while the population is a selected set. So why do we select a particular set? That is merely for the purpose of the easiness of conducting a survey. Get a small introduction like that, and then go and try to elaborate some differences also. Sample is where you have the entire set of population under the spotlight. Population, you select a set of subset based on the scientific method, probabilistic or non-probabilistic, whatever the mechanism which you are comfortable with, and then choose a set of values which has to be importantly unbiased and assumed to be representing the entire set of population. Write some examples also. Population would be the entire voting base of Sri Lanka. Sample would be selected 100 voters from each district ranging age 55 to 65, for example. Okay, comfortable? Let's move into the another question paper. 2017 March. Again, ladies and gentlemen, I'm focusing on question number 8. Let's read the question. Statistics involved in various types of data collected from various methods and sources. Compare and contrast following items related to statistical information. Just look at the these two papers. You will find even the introduction is very much similar. Here we have been asked to discuss the qualitative, quantitative, primary, secondary, sample and population. You could clearly see under question 8, subpart 3, same has been repeatedly asked by the examiner. So these are easy marks, ladies and gentlemen. The very first couple of sessions, students tend to get an understanding of this might be just for the introduction, but if you carefully look at, these are easy 10 marks for your pass mark to be a pass or a failure. It can be life-changing if you just get these theories into your head right first time with examples in a concise manner. Discrete variables and continuous variables. Now again, let's focus on what the examiner is asking. If the examiner wants to say write some brief notes on these matters that has been questioned, you might not really get the same approach to get an introduction, put up some similarities and put up some differences and maybe some examples. But here repetitively under these two papers, we could see it's a similar thing that he's questioning. What he's asking is compare and contrast. That means you will find some similarities and also you will find some changes or differences of the two values. Discrete variables and continuous variables. So discrete variables are, now we discussed data, but for data also you could say if you classify that particular data point under some sort of a variable or a x or a n or a p or a t which we assign to study it further and further, we could rename the data point as discrete data to discrete variables. So simply the variable, we'll be studying these variables in a different section. However, the idea of being converting the data into variables is merely just to show that we are observing or we are collecting more data under that particular variable for us to get understanding or for us to derive more conclusions on the matter in hand. So the broader difference is discrete could have multiple points or multiple integer, multiple points defined by some another party. Unlikely in the continuous variables where you will have n number of data in between another data point towards the infinity. That answer would suffice. And similarities, both are data, both are again quantifiable, numerical, both can be measured and recorded with other data. Both could be classified under different sampling methods for the studies. Can be many similarities you can write. Subpart number 3, qualitative data and quantitative data. Again, what we discussed a moment ago. If you look into more question papers like ones that I put here, September 2018, again question number 8. Look at the same thing. They're asking define between qualitative data and quantitative data. Now, in this question, let's see how the examiner's answer will be changed from your previous examination question. Let's read the question. It says, statistics involved in various types of data collected from various methods and sources. Briefly discuss the following concepts related to statistical information. Now, examiner is not categorically asking you to do a compare and contrast. So here you are even more free. If you don't write any similarities and differences, your marks will not be penalized by the examiner. This is where you can write your answers in an essay manner or a point by point manner the way you want. Basically, if you can reiterate the entire set of theory in a very brief manner for the 8 or 9 minutes under the clock, that would suffice. I'll show you one more exam paper before we wind up the session. This is 2019 September. Again, question number 8. Let's look at the question. Statistics involved in various types of data collected from various methods and sources. Briefly discuss the following concepts related to statistical information. Again, we're asking the qualitative data and quantitative data, primary and secondary sources. So, if a student asks me a question, okay, for an open-ended question like this, should we always try to write the similarities and differences and some examples? I would say it's a good practice. Because if you want to discuss under a particular subject portion, if you merely write this is it and this is how it works, you might tend to miss certain things. You might not tend to do some sort of fair judgment on or a weighting of side A to side B, and show the examiner that you know the differences and the similarities. So I would say even if the examiner invites you to briefly discuss, it's a good practice to get an introduction on the sections. In this section, you may write this is what on the qualitative data. It's a quality that can be gathered for a different basket or a ordinal manner. On the quantitative data, it's numerical, quantifiable data. It can be sometimes discrete, sometimes continuous. And then, similar to the compare and contrast answer, you may tend to write some of the similarities and some of the differences between these two can be like this. And let's look at some of the examples for qualitative data and quantitative data. You write qualitative data, good example would be gender. Quantitative data would be the weight of a person. If you could write that under 9 minutes, you tend to get 5 full marks without any hesitation, guaranteed. That's about it. We have 10 more minutes. If I try to get a brief wrap up of the today's session, before we get a small chance on discussing some of the questions which you have in mind, let's look into what we discussed today in a nutshell. We discussed the statistics. We got ourselves into the jargon of a few terms, statistics, important 4 points on statistical process. We collect data, organize them and present them, we analyze them and finally come to conclusions. We discuss many usages, characteristics, importance. So these are general things which will be hardly being questions, but you need to get a very brief understanding on the subject matter. Then we discuss some of the industries which we could see the heavy usage of statistics in their day-to-day operations. Again, we discuss some of these important things like the misrepresentation or misinterpretation of statistics without doing a proper comparison or proper analysis. Then we came to the second section of the session where we discussed the data and information. Data is merely the raw form of matters, while information is from a particular process being converted into a meaningful way for us to get an understanding. More jargon on statistical data and statistics is also being defined here. And then we try to work out some of these examples on the segregation between data and information. Then we discuss some of the broader type. This is the most frequently used types, the type in classifying the types of data into qualitative, quantitative, nominal and ordinal, discrete and continuous. We discuss some of the examples and their characteristics, both qualitative and quantitative. We worked out some of these examples. We tried to see whether it's a qualitative or a quantitative, and on our ordinal, nominal versus discrete and continuous. So there can be some of the other segmentations and segregations also into data. These are some of the used methods. Unlike the types of classification, also merely we could see that these are sampling methods also, which we'll be discussing in the other parts of the lecture series. Third section we discuss on the sources of data, primary, secondary sources, their advantages, disadvantages, uses, practical problems, and easinesses. We try to distinguish between the sources, whether it's primary and secondary. The easiest way is that if we try to do a survey or a gathering of data ourselves, that is primary. On the other hand, if somebody else publishes it, it's secondary. Last section, we discuss on the population and the sample briefly. And the sampling methods we'll be discussing on the next week under the probabilistic and non-probabilistic sampling methods with extensive examples and workings. And that's about it. Okay, so we have a few more minutes. Shoot any questions you have. You can turn on your microphone, or you can use the chat. Or even if you want to defer the question to a next session, that's okay. I'll try to find an answer for that also. So do you think it's a good choice that you selected this subject? Something which I have in my notes and which I forgot to mention in the first couple of minutes is that by choosing this subject, you have done a wise thing to get some background for the next level. There's a subject called financial management, I believe, FM. It's a bit of a difficult subject. The pass rates are comparatively low to the other subjects, but you have a lot of calculations, present values, project appraisal, cost of funds, portfolio theory, like a similar structure. You tend to have one question on open-ended answers, one question on the MCQs, but those examination papers can be a bit tricky. So this is one of the best subjects in the level 1 in the IBSL curriculum, where you will get the basic theories which you can get yourself enhanced when you are learning that subject on your level 2. Be mindful, that's a compulsory subject. By selecting this, getting your hands on the theories of maths and statistics, you will be very much equipped with greater understanding when you move to next level. So the floor is open. If you have anything, just I can hear, or you can type it on the chat. Do you think it's a difficult paper to pass? What's your opinion? I see no response. So that means, okay. I would say when we were preparing these slides, it's also we went through some of your past examination papers. I would comfortably say if you spend your 15 minutes of read time carefully, this first question anyway, it's you don't have to read it in the first 15 minutes. There's no choice in it actually. So when you are spending your 36 minutes on the right time, you can spend your time on first question itself. But if you carefully evaluate the pattern of examiners' testing, you might find really easy answers hidden in some of the questions. From the face value of it, let's say if you look at subject matters like linear programming or project appraisal or some of the theories which you will have to have multiple equations in your mind to answer, those can be tricky questions. But for a student who is comfortable with those areas, it's perfectly fine to choose these questions. But you really look at the first question and if you practice yourself with the last 10 past papers of the question number one, I'm sure there'll be at least 60 or 70% of the areas that is being tested again and again. For example, when you have time and when you get your hands on the question papers, just look into the first question. There'll be always a question on mean, median, and mode, which we'll be discussing under lecture 3. You'll be asked to define some characteristics, very basic characteristics, which is used for what, which is higher than which one, or under population, what you could see, whether it's being same or diverse or skewed. Those are characteristics similar to what we discussed under today's lecture. Those will be theory. And there'll be another question on index. There'll be another question on a treasury bill price or a treasury bond price. So, ladies and gentlemen, now those are things which you will practice a couple of times and then get hands on and easily gather 2 or 3 marks. So, categorically, if you practice yourself for question number 1 and question number 8, and if you're successful, we're talking about out of 40 marks, at least gather 30 marks. So now how many marks do you more want to pass? Just come to the pass stage. I'm not trying to limit you to 45 marks and stop it there, but just 15 marks, right? So you have ample of another 3 questions just to score the 15 marks. So I would easily say if you focus carefully on the areas that has been repeatedly questioned again and again, you can easily pass this subject in one go this time. There are some more questions flowing in. If you do some past papers, then it will be much easier, I think. Of course, that's what we're trying to do here, Hasita. After each lecture session, at the last bit of slide, we'll be discussing the theories that is being extensively tested under that subject area. So over the time that when you go towards the lecture series, you will find that at least 70 to 80% of the questions will be covered, and we'll try to do 1 or 2 mock exams also close to the examination. Uh, there's another question. Can we use Casio FX 100 MS calculator? I believe so. So as long as the Casio FX series is a non-programmable one, so that would be comfortable. What's the calculator model you mentioned? I'm really sorry. That's like an ambulance letters you can see on the other side. It's Casio 991 ES Plus, the calculator that I've shown here. Similar to this one, there are many other calculator series in 991, MS, ES, so on and so forth. So all are non-programmable, but just be careful when you are going to buy one. Just ask from the store whether it's a programmable or non-programmable, and do some googling also. I'll give you some recommendations also if you go to places near University of Moratu, University of Sri Javardhana, University of California. There are some book stores who will be giving you these calculators at the best prices because there will be a lot of university students who are using these calculators. Make sure you don't buy a calculator which has programmable features, then otherwise you'll be falling into trouble at the exam hall. All right, everybody. Thank you for your time. We don't see much crowd here today. We believe with time we'll have more people joining. And also, I believe these lectures will be available for you to refer later also with the IBSL. We'll check and confirm that. And hopefully, let's meet in person when the situation cools down and when we are able to come out and interact socially with each other. So until then, thank you. We'll meet up on next week. And very be mindful, just follow the exercise that we are sharing with you on a regular basis, and you don't have to study for the exam in the last point because we are covering all the exam questions at the last part of each and every lecture, and 1 or 2 mock exams will elevate you to the position where you will pass the exam in the first run and then comfortably move with your rest of the subjects. All right, good luck, have a good evening, bye bye.